Somewhere around a dying fire, a child cannot sleep. The rest of the camp is quiet. Adults, exhausted from a day of moving and hunting, are already gone. But she is sitting up, listening. Not to anything specific, to everything. A shift in the air pressure, a bird that stopped calling 2 hills over, a sound that simply isn't there anymore. Nobody else woke up, nobody else noticed. In the morning, someone would find her there, still watching the dark, and the word they would use for her, in whatever language that camp spoke, would translate roughly to too much, too aware, too easily startled, too moved by things that didn't move others. 30,000 years later, that same word is still being used. It just wears different clothes now. Oversensitive, anxious, easily overwhelmed. We say it about children who cry at loud noises, who feel other people's moods like weather, who can't watch certain films because the emotion hits them somewhere real and unmanageable. We say it like it's a problem waiting to be solved. Nobody stopped to ask why a brain would be built that way. Nobody asked what it was made for. If you're enjoying this story so far, don't forget to hit the like button and subscribe. Drop a comment telling me where in the world you're watching from. I love hearing from you. The common understanding of sensitivity is that it's a spectrum, and somewhere past a certain point, you've got too much of it. The logic seems reasonable on the surface. Hard environments made hard people. Survival selected for those who didn't flinch. A child who cried at the wind would have slowed the group down. There's some truth buried in there. But it doesn't account for one consistent, inconvenient fact. In 1996, psychologist Elaine Aron at Stony Brook University published research that would eventually reshape how scientists understand human personality. She identified a trait she called sensory processing sensitivity. What she found was that roughly 15 to 20% of the human population processes sensory and emotional information at a measurably deeper level than everyone else. Not louder, deeper. These brains don't just register an experience, they run it through more processing before returning a response. They notice subtlety that other brains filter out. They hold on to emotional information longer. They are affected by things that leave others unmoved. Aron didn't frame this as pathology. She framed it as a biological variant that had survived every pressure evolution threw at it, which raised an uncomfortable question. If this trait made daily life harder, which it often does, why is it still here? The answer starts with how ancient groups actually functioned. Anthropologist Christopher Boehm spent decades studying contemporary hunter-gatherer societies, and his 2011 book, Hierarchy in the Forest, drew on field research across multiple cultures. What he found, consistently, was that these groups were not collections of identical personalities. They were distributed systems. Different people carried different roles, and those roles weren't all about physical strength or hunting skill. Some of them were about attention. Boehm documented what other researchers had begun to notice as well. In small foraging bands, certain individuals functioned as what could now be called social monitors. They tracked the emotional temperature of the group. They noticed when someone was withdrawing, when an alliance was fraying, when the mood of camp had shifted in a way that predicted conflict. These weren't the loudest people. They were the ones who processed everything quietly, continuously, and at a level nobody else could maintain. In a group of 20 to 30 people moving through unpredictable terrain, that function wasn't decoration, it was survival infrastructure. The biology supports this. In 2014, researcher Bianca Acevedo at the University of California used fMRI imaging to study the brains of highly sensitive people. What the scans showed was that regions associated with awareness, empathy, and integration of complex information were more active in sensitive brains during ordinary tasks. The brain wasn't overloaded. It was running more, processing more input, connecting more threads, holding more variables at once. That is an energetically expensive system to maintain. It costs something to live in a body like that. The question Acevedo was quietly asking was why any organism would pay that cost unless it was getting something back. If you're hooked on this story, make sure to subscribe and turn on notifications so you never miss an upload. Your support means everything and helps me bring you more emotional stories like this one. The answer, across multiple animal species, turned out to be consistent. Biologist David Sloan Wilson studied the trait in Pumpkinseed sunfish in 1998 and found that a subset of the population consistently behaved with greater caution, greater attention to environmental shifts, and greater responsiveness to threat. The fish with this profile paid a cost in normal conditions. They were more reactive, slower to exploit resources, but when conditions became dangerous, this group outperformed. They detected predators earlier, they adjusted faster, they survived at higher rates when the environment stopped being predictable. Wilson called the trait evolutionarily conserved. preserved across deep time and across species because the conditions that made it valuable kept recurring. Jerome Kagan at Harvard University spent 30 years studying what he called behavioral inhibition in children, publishing his key findings in his 1994 book, Galen's Prophecy. He followed groups of children from infancy into adolescence and found that roughly 15 to 20% showed consistent physiological signatures of heightened sensitivity to novelty and threat. Elevated heart rates, larger cortisol responses, faster startle reactions. These children were not more anxious in a clinical sense. Their nervous systems were running a higher baseline alert. Kagan noted that the same physiological profile appeared consistently across cultures, which suggested it wasn't a product of upbringing alone. The sensitivity was in the architecture of the nervous system itself. Go back to the child at the edge of the fire. She wasn't a problem the tribe was managing. She was a function the tribe couldn't afford to lose. She heard the bird go silent 2 hills away because her brain was built to hear it. She felt the shift in the group's mood 3 days before the argument broke out because her nervous system was running a continuous read on the people around her. She cried at things others didn't feel because she was registering signals others couldn't access. The camp slept because she was awake. That was the arrangement. It wasn't spoken, but it was understood. Here's where this tends to land differently for people who recognize themselves in this. The daily cost of high sensitivity is real. The overstimulation, the emotional weight, the experience of being moved by things nobody else seems to notice. None of that is romanticized away by knowing its origin. But there is a genuine distance between a hard biological role and a defective one. These brains weren't poorly calibrated versions of the standard model. They were a different instrument, tuned for a specific frequency the rest of the group couldn't pick up. Consider what that frequency actually detected. Anthropological data from the Hadza people of northern Tanzania, one of the last continuously practicing hunter-gatherer groups on Earth, shows that camp decisions about movement and conflict resolution were rarely made by the strongest or fastest individual. Frank Marlowe, who conducted extensive field research with the Hadza beginning in 1995, documented that group cohesion depended heavily on individuals who could read interpersonal dynamics accurately and flag tension before it became rupture. Those individuals tended toward quieter, more watchful behavioral profiles. The group needed their read on the room. In many cases, the group organized around it. The environments changed. Schools arrived. Open offices arrived. The demand to process only what is directly in front of you, to not be affected by what's happening across the room or underneath what someone is saying, that arrived recently and loudly. The brain didn't change with it. The shift happened fast, in evolutionary terms. For roughly 300,000 years, the sensitive brain operated in an environment it was built for. Small groups, sensory input that was immediate and consequential, social stakes that were visible and close. Then, within a few thousand years, humans moved into settlements, then cities, then institutions. The new environment rewarded a different cognitive style entirely. Not depth of processing, but volume of output. Not signal detection, but task completion. The sensitive brain, flooded by a world generating more stimulation than any nervous system could meaningfully sort, got labeled as the one that couldn't cope. So the child who felt everything grew up and was told she felt too much. The teenager who cried at the news was called oversensitive, as though the news wasn't worth crying at. The adult who walked into a room and immediately knew something was wrong was told they were imagining it, usually right up until they turned out to be correct. The trait didn't become a problem. The world stopped knowing what to do with it. That child at the edge of the fire is still here, sitting at the edge of rooms, noticing what rooms do, reading what nobody said out loud. Lying awake because something shifted, and the shape of that shift hasn't resolved into language yet. Being affected, processing, running the deeper scan while everyone else sleeps. For most of human history, the tribe knew exactly what to do with a person like that. They let her stay awake. Thank you so much for watching until the end. If you loved this story, check out the other videos on your screen now. I think you'll really enjoy them. And don't forget to subscribe if you haven't already. See you in the next story.